Pencils go down onto your desk. Colored pens come up. Today's warm-up is critical for a number of reasons. One, it's a mini quiz of the last lesson. But two, it also leads us into today's lesson. So it actually has a twofold purpose. So let's see how we're doing with compound inequalities. Number one, what did you get as your solution? We'll start with Marcus, Amari, Cheyenne, and then Kaylee.
X is less than -4, or X is greater than or equal to -1.
Okay, what'd you get, Amari? Okay, so that was similar, but I think there was a small difference. Cheyenne, what did you get?
X is less than -4, or X is greater than or equal to -1. What Marcus?
Okay. Kaylee, what did you have?
X is less than -4 or X is greater than.
So we end up with X is less than -4 or X is greater than or equal to -1. Unfortunately, if one of your inequality symbols is facing the wrong direction, that is incorrect. If it's just a situation that you read it wrong, but you actually have it written down correctly, that's fine. You can mark it correct. All right? We'll get back to the how in a moment. Number two, what did you get? We'll start with Adriana, Tristan, Garion, and then David.
3 is greater than or equal to X, and X is less than -1.
Okay?
X is less than 3, and X is less than
Okay. Garion?
X is greater than -1 and X is less than 3.
Okay, so I'm hearing the same numbers over and over again, but I'm hearing a different interpretation. David?
X is greater than 1.
Okay, so we do have some disagreement on how this should be. This is the correct answer, but before you mark your answer right or wrong, I will accept one other answer. I'll accept it today, and then I'm never going to accept it again. If you wrote this, I will accept it for today. Then I'm going to explain why it's not really okay. Excuse me for a quick moment. I apologize. So, if you wrote this, this is okay for today, but after today it will not be okay. Could someone tell us what's wrong with this? There's something terribly, terribly wrong with this. Tristan, what do you think's wrong with it?
I put that, but I know what's wrong with the -1 is supposed to be first.
Very good. So the smaller number should be on the left because on a number line, smaller numbers are to the left. So what do? How did we get from here to here? Well, it's very simple. Flip the entire thing. So watch. I'm going to do this using the power of the computer, but it's going to be a little bit weird, so just watch. So we flip it around, and look at what happens. Yes, I know my numbers are backwards because it did a mirror image, but look at the arrows. Look at the arrows here and look at the arrows here. When you flip the entire thing, you're creating a mirror image of it, but the smaller number moves to the left and the bigger number is on the right. So what you have to be careful of is the arrows facing the correct direction. So let me back up for a second and let me do this a different way. And let me transform it by doing a flip. And so watch. This is correct. That's incorrect. See, the whole thing is flipping. The whole thing is flipping. Okay? So that's what you have to learn how to do. Anyone have any questions about that? Any questions? Okay, well, I walked around and I saw a very high performance rate on the homework. So let's now look at this and take a survey. Give me a thumbs up if you got both questions correct. Okay, put your thumbs down. Remember, thumbs up system means you put your thumb around here so that it's easy for me to see what you're talking about. Okay, any comments or questions on today's warm-up? All right, so let's hit the poll. So today, we're going to end chapter 2 by basically taking the culminating everything we've done for the entire chapter, bringing everything together in some complex situations that involve absolute values. So the work we're going to be doing is challenging and very detail-oriented. I've been saying this a lot, that Algebra 1 Honors is about the details. That's going to be incredibly true today. You're going to use a lot of skills that you already know. You're going to learn a few new things today that are difficult to work with. Let's talk about the progression that we went through. Chapter 1, we started with one-step equations, went to two-step, multi-step with variables on both sides. Then we did absolute value equations. And there was something unusual about absolute value equations. Don't tell me, but I want you to try and think back to what was unusual or different about absolute value equations. Don't tell me, just think. Then we reset. Beginning of chapter 2, it was like we started all over again. We did one- and two-step inequalities. Then we did multi-step inequalities, and then inequalities with variables on both sides. And then we did something new, compound inequalities. And now we are here. Everything we've done leads to something new. And today is built on everything we've done already. So, an absolute value inequality. The biggest point I want to get across to you initially is that an absolute value inequality is a fancy way of writing a compound inequality. An absolute value inequality is a fancy way of writing a compound inequality. Here's an example of an absolute value inequality. It's an inequality, and there's an absolute value symbol in there. And the variable is inside the absolute value. So that's written in algebra. Here's it written in English. All real numbers whose distance from 0 is less than 5 units. And that is the key right there. Distance from 0 is less than 5 units. So I want to talk about that for a moment. We spent quite a bit of time last time we were together graphing. And so if we draw a graph, and I put a 0 right here. And we'll just say 1, 2, 3, 4. And I left myself short, so I'll put in a 5 right there. -1, -2, -3, -4, -5. Can someone, or several people, give me a number from the number line that is less than 5 units from 0? So I want a number whose distance is less than 5 units from 0. So hold on a second. Should we? So Amir, you've been waiting. Can you give me a number that's less than 5 units away in distance from 0?
Negative 4.
Negative 4. Is that less than 5 units? Let's see. 1, 2, 3, 4. Yeah, that's less than 5 units away. Karen, you had 1 as well. Give me another one. 2. He thinks 2 is less than 5 units away. Let's see. 1, 2. Yep, that's less than 5 units away. Give me another one. Marcus?
3.
3. Let's see. 1, 2, 3. Yep, that's less than 5 units away. Give me another one. Cheyenne? Negative 3. 1, 2, 3. Yep. Give me another one. Amani? 1. 1. Yep. Okay, Chopin, give me another one. Well, 0 is kind of our starting point, so 0, yeah, is less than 5 units away from 0. So, yeah, you're right. Okay, I'll buy that. Give me another one. Alex? Negative 1. Yep, that's 1 unit away. Give me another one. Michael? Negative 2. 1, 2. Good. Give me another one. Caleb? 4. 1, 2, 3, 4. Good. Give me another one. Tristan? 5 is 1, 2, 3, 4, 5 units away. That's not less than 5, that's equal to 5. So, unfortunately, that one doesn't count. Okay, Adriana? 1.5. Half, 1, so that's 1.5 units away. Beautiful. Give me another one. Gary? 2.3. So I'll estimate that to be about right there. So that's 0.3 and then 1, 2, so 2.3 units away in distance. Give me another one, Cheyenne.
4.4.
4.4, so that's approximately right there. So that would be 0.4 and then 1, 2, 3, 4. So 4.4 units away. Any others? Any other? Go ahead, Tristan. 4.99. So that would be like way over there. So is this what we do when we graph in my class? We just keep putting dots?
No.
Do I have to keep going and going and going and going and going until I hit every dot?
No.
Like, so what would be a better approach? What could I do at this point? Who's caught on to what's happening here? Cheyenne?
Shade in all the numbers.
Yeah, I could shade in all the numbers. But here's the question. Where do I stop? You already got a big clue. Tristan helped you out a lot. Where do I stop? Amir? Anything that's what? So I stop.
Yeah. Any number. No. You stop.
Okay. Catalina?
Open circle on 5.
Yeah. We put an open circle on the 5 because, as Tristan pointed out, the 5 doesn't make this true, but 4.99 would make it true. 4.9999999. I mean, we could go on and on and on. Is that the only point that's going to get an open circle based on what you've seen so far? Amari? Yeah, because that is also going to be 5 units away in distance, and we need less than 5. So then what we would do is this. We shade in everything in between, right? That's representing all the numbers that are less than 5 units away from 0. And look at how we write this. How do we write this? It's right here. It was already up here the whole time. So this graph is this right here. And could someone tell us what is this called? What is that called? Many of you told me you got 9s on the lesson, 9s and 8s. You should be an expert if you're telling me that. Keshupe? Okay, very good. It's a compound inequality. Could someone, oh, we got some anxious people? Yudesh? Yeah, since there's 2 kinds, you have to know that that's an and compound inequality. So that's an and so what we just figured out was this, that, excuse me, that this is the same thing as this and the same thing as this. So in actuality, today we're not going to really solve absolute value inequalities. What we're going to do is we're going to convert them to compound inequalities because we are experts at that. Once we convert, we solve the compound inequality and then we graph. Okay? So it is not easy, so we're going to jump into the process, but it's challenging enough that I want you to have some steps that you could refer back to. Because I think when we do it, you're going to be fine, and it is hard and it takes a lot of effort and time, but I think you'll get it. But the problem is that today's Friday and tomorrow's Saturday, and you'll do your homework maybe later tomorrow or maybe Sunday, and you're not going to remember what we did today. And so then you're going to be like, well, oh, I don't know what to do. So then you have to have something to fall back on. And so that's when I like to outline some steps for you. And so here are the steps outlined for you. Now, the outline does not tell you everything. Tells you most of it, but there's some details that you have to pay attention to. So step 1 is not new. Isolate the absolute value on one side of the inequality. That you did when we did equations. We isolated the absolute value, so everyone in the room knows how to do that. Step 2 is brand new. Rewrite as a compound inequality. As Yadesh pointed out, there are 2 different types, so you have to know how to convert to the right one. If the symbol is a less than symbol, which is one of these, then we write a compound inequality with and. If it's a greater than symbol, then we write a compound inequality with or. So there's 2 different ways it can go, and you have to know which way is correct. Once we have it set up as a compound inequality, you solve the inequality. So steps 1 and 3 are not new. You already know how to do both of them. The only thing new today is step 2. And we're going to start our efforts by really working hard on step 2, and then we will do the entire process. So I'm going to give you a moment to jot this down. Remember to use abbreviations. Absolute could be abbreviated ABS. Value could be VAL. Compound could be COMP. Inequality could be INEQ. Use lots of abbreviations. Take a moment, and then we'll continue. Now, step number 2 is where most of our effort is going to be, because we already clarified that we already know how to do numbers 1 and 2. The good news is, and you see these 2 little stars here, that's because I have a memory device for you. The memory device is a little bit silly, but it works. And I know it works because I've been using it for 8 years, and it works every single year. So you're going to remember 2 words, and the words are nonsensical words. They're not words that you're going to use in everyday language. But you'll remember them, and they have important meaning. The 2 words you're going to remember are gore and land. Goreland. And the reason it's important to remember is because the words translate into something important. The G in gore stands for greater than. The L in land stands for less than. And so you translate it, the G is for greater. That translates the absolute value inequality into an OR, compound inequality. The L, less than, translates into an AND inequality. Now, there's actually more to it. There's a couple of details that if you don't do, you will get the whole thing wrong. So we have to make sure we're clear on those details. And as I've said a whole bunch of times, Algebra 1 is about the details. So we're going to practice the idea of Goreland. So we're going to not worry about step number 1, and we're not going to worry about step number 3 to start with. We're only going to worry about step number 2 and how to apply this memory device, Goreland. And we're going to do it by doing some rapid-fire conversions. So we're going to start with the one on the left. The absolute value of 5x minus 7 is less than or equal to 23. When the absolute value is isolated, it's isolated here. If it wasn't isolated, we would have something like this. But we don't, so it's isolated. You already learned that. You learned that at the end of chapter 1. So step 1's done. Now we're ready for Goreland. Writing it down helps. Writing it down helps. So Goreland is based on the inequality symbol. So now we're looking at this symbol, and we're saying to ourselves, is that a less than symbol, or is that a greater than symbol? So now I'm going to survey, and let's see if you know which one it is. Give me a thumbs up if you think that is a greater than symbol. Okay, give me a thumbs up if you think it's a less than symbol. Okay, so you didn't put your thumb up for the first one, you didn't put up your thumb for the second one. So you don't know what it is, or? Oh, well, you got to be clear, because it's doing this is not really helping anybody. Okay, so this is a less than symbol. That's a less than. You start reading from left to right, so that is less than 23. So this is a less than symbol, which means we are going to translate this to an AND inequality. An AND inequality, you'll remember, has the x terms in the middle and then some numbers on the outside. So we are actually going to take this entire inequality and rewrite it right here. But we're going to drop the absolute value symbol. So here's what we're going to write. 5x minus 7 is less than or equal to 23. So we are copying this exact same thing, but we're getting rid of this and we're getting rid of this when we rewrite it. We're not done yet. That wouldn't make any sense to just rewrite it and drop the symbol. That's not converting, that's making a mistake. This is also not an AND inequality. An AND inequality has another symbol over here and another number. So now we need the other symbol and the other number. And it's quite simple. We take the same exact symbol and we're going to copy it right over here. And we're going to take the same exact number And we're going to copy it over here, but we're going to make one adjustment. Wouldn't really make sense to put a 23 there, would it? How could it be 5x minus 7 is greater than or equal to 23 and less than or equal to 23? That doesn't make any sense. So what adjustment do you think we're going to make? And you saw this last time. Laurel? Yeah, it's going to become negative 23. So you copy the symbol and flip the sign. And so what we've done is we've rewritten the whole thing except this part comes from our brain. You have to add that part in. And that is converting from an absolute value inequality to a compound inequality. Any questions on how we did that? And we use the memory device Gourland to help us. Any questions? So let's look at the next one right here. X minus 9, the absolute value of x minus 9 is greater than 1. Again, the absolute value is isolated already. If it wasn't, we would have something like this. But we don't. So we know it's isolated already, which means we're ready for Gourland. And that's based on the symbol. So let's look at the symbol. Give me a thumbs up if you think this is a greater than symbol. Okay, put your thumbs down so my students who didn't put their thumbs up think it's a less than. This is a greater than symbol because we're reading from left to right. And what do we hit first? We hit the open mouth first. That's greater than. So this is a greater than, which means we are going to convert this to an or inequality. Converting to an or inequality is a tiny bit more complex, but really not terrible. You already know from the last lesson that an or inequality has the word or in it. So go ahead and write down the word or. And we're going to copy this exact inequality over to this side. But we're going to drop the absolute value symbol. So we're going to write x minus 9 is greater than 1. But it is not a compound inequality unless we have another inequality over here. And so we're going to actually copy the exact same thing. It's going to be x minus 9, but then we make 2 adjustments instead of 1. What's the first adjustment that we already know about? Michael? Ah, very good. So, yeah, we flip the sign, and then what's the second adjustment? Tristan? That's right. And so the adjustments that we have to make are right here. So I call that flip the symbol, flip the sign. Flip the symbol, flip the sign. Flip the symbol, flip the sign. And that's what we did right there. So I would note that because you're going to do it a bunch of times today and you'll remember, but then when you go home, you're going to forget. And you need to get good at this to the point where 3 weeks from now you remember, and 5 months from now you remember. Okay?
Isn't like another way to remember it, when you're doing an inequality, absolute value inequality with the word and, doesn't, and when you're trying to get the sign on the other side, doesn't it mean that, don't you mean like, isn't the sign always facing that way?
Yes, it is.
And on the next one, the signs are always facing the right.
That's right. So if you just kind of think of it logically, it makes sense. This symbol will always be pointing to the left, and so will that. It doesn't really make sense any other way. You're absolutely right. Very good. Any other comments, questions? All right, let's see a couple more, and we're going to go quicker now. And I'm going to ask a slightly different question this time. So this says the absolute value of x plus 200 is greater than 340. I'm not going to ask you what type of symbol that is. I'm just going to ask you, what are we going to convert it to? Are we going to convert it to an or are we going to convert it to an and? What do you think? Yadesh, what do you think? Think an or? Laurel, what do you think? You think it's an or? Yeah, because this is a greater than symbol, we're going to convert it to an or. So we can immediately write the word or in between, copy the exact same inequality but drop the inequality symbol, and then rewrite it again but do the two little adjustments. Flip the symbol, flip the sign. So we've got x plus 200, flip the symbol, flip the sign. Does anyone have any questions on how we did that? Or comments or anything? Tristan? Well, yes, but I said that we are not going to focus on steps 1 and 3. We're just going to focus on step 2. Step 1, isolate. I already took care of that for you. And step 3 is solve. We're not going to do that yet. We're going to do it in a moment. Okay? I wanted to focus on conversion. Any other comments, questions? Now, I have 3 more, but I don't think we need them. I think we've got the idea of Gorland and converting down pretty well. So I'm going to skip the other rapid-fire questions, and we're going to go to a formal question. And now we're going to do the process from beginning to end. Okay? So solve the inequality. The absolute value of 5x minus 7 is less than or equal to 23. I just used this example during the rapid fire round. So now we already have it set up. So we can just copy from what we did before. And then we're going to solve the whole thing. But let me just back up for 1 second and remind you that the absolute value is already isolated. So step 1's already done. We used Gorland to convert this from a less than to an and. And so we rewrote it like this. And then we knew immediately to put that there and a negative 23 here. Any questions about how we got to the compound inequality? Any questions about how we got to here? Good, so now we solve. And again, if I could go look at my grade book, I've got 7s, 8s, and 9s in this room on solving compound inequalities. I should be able to call on any single person in the room and you should be able to tell me the first step. So what's the first step? Gary?
Add 7 to all sides.
I love the way you said that. Add 7 to all sides. Elementary school line, working down. Negative 23 plus 7 is negative 16. This cancels out, and we're left with 5x. And we got 30. Amani, what is the next step in solving? Again, said beautifully. Divide all sides by 5. This cancels out. We're left with the x in the middle. We didn't multiply or divide by a negative number at any point, so the symbols stay the same. 30 divided by 5 is 6. Negative 16 divided by 5, we don't need a calculator for that. Just rewrite it. What does it come out to, David? Oh, we don't need to use a calculator. That's waste. Okay, but we don't need it in decimal form. There's no decimals in the original, so yeah, it's negative 3 1/5. So I'm sorry. I thank you for telling me you didn't use a calculator. That's 3 1/5. Sorry. 3 1/5. So yeah, it's 3 1/5, which is he's right. Is negative 3.2. Very good. And that is solving an absolute value inequality. Any comments, questions, concerns on how we did this? On how we got from here to here, or here down to here? Any comments or questions?
I mean, I'm supposed to know this, but how do you get to the fraction form?
Negative 16/5. How many times does 5 go into 16? Oh, you said 3? Yeah, so it goes in 3 whole times. And how many are left over after we do that? 1. And it's a negative, so it's a negative.
Oh.
No, just don't have enough experience with it, but you should be, honestly, at this point, you should really have no problem with that. But now you know. All right, any other comments, questions? All right, so let's do the second rapid fire example that I used before. Again, for this first formal example, I eliminated step 1. You do not have to worry about it being isolated, it's already isolated. And we already converted it during the rapid fire round, and since this was a greater than, we converted it to an or. And you'll remember that it looked like this. Flip the symbol, flip the sign. And you'll remember from last time that solving an or inequality is simple. You just solve both of them separately and connect them with the word or. You'll also notice that the transformation is the same on both of them. Add 9 to both sides. That cancels out. X is less than 8. Add 9 to both sides. That cancels out. X is greater than 10. Drop down the word or. And we get x is less than 8 or x is greater than 10. Anyone have any comments or questions on how we did that? Comments, questions, concerns? On anything? All right, let's see how you do on your own. Checkpoint number 1. You got 3 minutes to solve this absolute value inequality. Good luck. You got 1 minute to team talk. See how your answer compares with your teammates. Go.
I got x is less than or equal to negative 56 negative 16.
All right. Give me a thumbs up if you and your teammates came to an agreement on the solution. A thumbs up if you and your teammates came to an agreement. Okay? Good. Put your thumbs down. Laurel, then Isabella, and then Adriana. Laurel, what did your team think it was?
X is less than or x is less than or equal to negative 56. I got the right answer. Or x is greater than or equal to negative 16.
Okay, Isabella, what did your team think it was? I think that's what you said, right? Okay. Adriana, what did your team think?
X is less than or equal to 56, or x is greater than or equal to negative 56.
So it was x is less than or equal to negative 56, or x is greater than or equal to negative 16. Unfortunately, if you put a positive number when it was supposed to be negative, that is wrong. And if you have the symbol facing the wrong direction, unfortunately, it is wrong. So, any comments, questions, or concerns on checkpoint number 1? Anything at all before we make it more complex? Catalina, and then anybody else? Well, what did you get?
Where's the divide?
Okay,
Divide.
so let's go back. So, could someone help us? Because I know of a bunch of people who got it right. What does this convert into, an or an and? Gary? Or. So we end up with 18 plus 1/2 x is greater than or equal to 10. And then on the left-hand side, it's going to be 18 plus 1/2 x, and what's the rest? What's the rest, Chanel? Less than or equal to negative 10. So that is what you learned today, is that to convert it, you have to do this right here. That's the key. Now solve both of them. What's the first step in solving both of them? Marcus?
You gotta subtract 18 on both sides.
Very good. Subtract 18 on both sides here, and that actually ends up being the first step here as well. You just end up with a different result. This cancels, and we get 1/2 x is less than or equal to negative 28. This cancels, and you get 1/2 x is greater than or equal to negative 8. You find your mistake yet? What was it? Okay. Oh, I see. Okay. Good. So I'm glad you pointed that out, because I'm sure you're not the only one who made that mistake. Anyone have any other questions about how to proceed? Good. So let's up the level of complexity a little bit by introducing the pieces that we didn't have to deal with before. So, example 3, and we're going to do part A here.
Practice example 2.
Okay. Okay, so it's example 2. Example 2A. Sorry.
That's fine.
So, now when I say up the level of complexity, it doesn't mean it's going to up the level tremendously. The one thing we have different in example 2A is that we have this plus 4 hanging out there. And we can't do anything unless the absolute value is isolated. So that's the first thing that always has to be done no matter what. So what do we do to get it isolated? Alex? Subtract 4 on both sides. Beautifully said. Subtract 4, subtract 4. Now it will disappear, and we're left with the absolute value isolated, which is what we wanted. Make sure you add down correctly. Now the absolute value is isolated. Now we can do Gorland. You cannot do Gorland before this, because if you do, you could end up making a complete mistake on how you set it up. So this is going to be an or an and. Which one is this going to be? Yudesh? It's going to be an or. It's a greater than symbol, so we're going to do an or. So we're going to rewrite this, copy this exact same inequality without the absolute value symbol, and then recopy it again on the left, but this time, flip the symbol, flip the sign. Now, solve the whole compound inequality. Again, I must point out that you guys told me that you're, for the most part, levels 8s and 9s. Master Jedis and Grandmaster Yodas of solving compound inequalities. So at this point, you should be feeling a sense of relief like, oh, I know how to do this. This is no big deal at all. I see a lot of you already forging ahead, so I'll just continue on as if we're parallel working. Add 3 to both sides. Add 3 to both sides on this one. This cancels out. And we're left with the 3x is less than or equal to negative 3. And here we do the same process but get a different result. We get 3x is greater than or equal to 9. Divide both sides by 3. We did not multiply or divide by a negative number. And so we end up with x is less than or equal to negative 1, or x is greater than 3. Does anyone have any comments or questions on how we did that?
I forgot to say or equal to 3.
Any comments or questions on this one? Okay, so now we bring back graphing. Now that we have a good idea of how all of this works, we bring back the idea of graphing. We'll say that this is negative 1, 0, 1, 2, 3, 4, 5, 6, 7. And we'll do a closed circle on the negative 1, a closed circle on the 3, and shade. So that is a lot of work. If you look at the whole thing together, we had quite a few steps, quite a few different parts. I mean, first we had to isolate the absolute value. Then we had to use Gourland to convert this to this. Then we had to solve this, which in essence was solving two different ones, put it together, and then graph it. A lot of different parts and a lot of work. Anyone have any comments or questions? Any concerns? Okay. Example 2b, and thank you for pointing out that this is supposed to be 2. Bless you.
Thank you.
So I'm going to use this example not entirely. I'm going to use part of it. So if this were a homework question, you would do the whole thing. But I want to use my time wisely, so we're going to use part of this. So we're still following the same process. Step 1, isolate the absolute value. So we have two things to get rid of to make the absolute value isolated. We have to get rid of this plus 5 and that negative 2. So subtract 5 from both sides. That's what will get rid of that. Disappears, and we're left with this. Now, you should be getting used to the fact that when you have an absolute value, you do not want a negative number on the other side. Because absolute value means distance, and we can't have a negative distance. However, that looks like this is the case, but it's not. Because we have not addressed this yet. And so watch what happens when we address this. To get rid of that negative 2, we divide both sides by negative 2. This disappears, and we now have absolute value of 6x minus 1 is less than 1, except, what did we just do? Marcus?
You divide both sides by negative 2, so you have to flip the symbol.
Yeah, we have to flip the symbol. And this is why you must wait to use Gourland till you have the absolute value isolated. If you were to use Gourland way up here, if you were to use it up here, this would be a less than symbol, and this would turn into an and. But in actuality, it's a greater than symbol, and in doing it correctly, we are actually going to end up with an or again. So you have to pay attention to what's going on. You cannot use Gourland until you get to here. So now we're ready to convert, and then we're going to stop this question. We're going to convert. We put down the word or. 6x minus 1 is greater than 1. Now rewrite the same thing, 6x minus 1. Flip the symbol, flip the sign. And now we would solve from there. We're not going to solve this one, but if this were a classwork question, a quiz question, or a homework question, then of course you would solve it. But my point has been made. You have to do the process before you can use Gourland. Comments, questions, and concerns? Catalina and then David.
Why did you distribute the negative?
Okay, you are not allowed to, because an absolute value symbol does not function like a grouping symbol. It does in some sense, and in other senses it does not. So you do not distribute when you have absolute value. That is an excellent question, but you can. And this was the same thing that we talked about. It was brought up when we studied absolute value equations. That was the first thing that someone said was distribute, but you cannot. You can distribute with you can distribute with parentheses, and you can distribute with brackets. Absolute value is sort of a grouping symbol, but has other rules. Okay? Very good question. Any other comments, questions? David?
What sense could be like, you said with the absolute value signs that we could distribute it some way. How would we do that?
No, I said in some senses it's a grouping symbol and in some sense it's not.
How's
It's a grouping symbol because this does have to stay together. So it is sort of grouped, but it does not function like other grouping symbols, such as being able to distribute. Okay? Good. So you're going to do a checkpoint in a moment. Give me a thumbs up if you predict you will get the checkpoint correct. Give me a thumbs up if you predict that you will get it correct. Good. Put your thumbs down. Let's see if you can make that happen. Checkpoint number 2. You got 3 minutes. All right, you got 1 minute to team talk. Compare your answers with your teammates and see how you did. You want to take the paper out and show it to them and hold them side by side? Whatever you want to do.
No, they're both negative.
-9 plus -5.
It's not plus, it's subtracting.
-9.
Oh,
That's
right.
right.
Yeah.
True. Idiot, my get for the first part. Dude, look, it's negative by -5.
Yeah, exactly. What?
No, it's not.
They're both negative.
If it's -5, it's not.
Yes, it is.
What Marcus? Okay. He's the one who hasn't answered yet. I was right. Oh, you put -7 too. It's not 14.
No, it's not 14 because we have to divide it.
All right. Let's see how we did.
-9 plus -9.
Give me a thumbs up if you and your teammates came to an agreement. Okay, some did, some didn't. That's okay. So we'll start with Kaylee and then Catalina, and then we'll come over to Cheyenne. Kaylee, what did your team come up with? Because you did not, or you said you agreed, but they didn't seem to agree. So let's see what you had to say.
X is less than or equal to -7, or X is greater than or equal to
Okay, Catalina, what did your team come up with?
2. X is less than or equal to -7, or X is greater than or equal to 2.
Kaylee, was that exactly what you said? I think it was. And Cheyenne, what did your team come up with?
X is less than or greater. X is less than or equal to -7, or X is greater than or equal to 2.
I got it right.
Yeah, that's wrong.
We both got it right, but he got it
No, that's
All right,
that's the
so-
wrong answer. No, it's not.
So you were supposed to graph. I didn't have a graph up here, but you should have graphed. Should have had closed circle on -7 and 2 and shaded opposite ends. So give me a thumbs up if you got the question correct.
Well, yeah, you can do it. That's not.
Okay, good. Put your thumbs down. So if you didn't get it correct, there is someone on your team who did. And so what your job is now is to take one of their papers, with their permission, and to look, compare your work to theirs, and see where you went wrong. Any comments about checkpoint number 2? Seems like most of you, your prediction came true. That's pretty good. David, your question or comment?
No, you're not allowed to.
Hold on. Go ahead. Okay, so I'll come take a look in a moment. All right. So usually we lead. I take you down a path where we explore an idea, learn how to work with it, in the hopes that we can apply it to real-world scenarios. Sometimes the real-world scenarios are tough for you to imagine because they're real worlds, they're not necessarily your world. Your world is the world of a 13, 14-year-old. The real world, we're talking about doctors and lawyers and transportation and engineering. When I say real world, I'm talking about all that stuff out there. So don't get frustrated when I say real world and you think I'm going to talk about video games every day. That's not what it's going to be. Real world means the real world out there. And so here is an actual application of the idea, and it's from the medical field. So everyone should have written example 3, and do not copy the question because it's too much to copy, and just read it to yourself. First of all, does anyone have any questions about the scenario itself? No? Not surprising. I've done this with 2 other classes and there was some major questions. Yes?
Is that real? Like, you must be 95 degrees.
Yes, that is very real. And I had a lot of students in other classes who thought that was very odd that you would put a baby in water that was 95 degrees. It seems like that would be like scalding hot, but it's not. 95 degrees is actually perfect temperature. It's perfect temperature for bath water. And to test that out for yourself, if you have a thermometer that you're allowed to use at home, you can ask a family member. I would ask you to fill up the bathtub a little bit. Not to take a bath, but fill up the bathtub a little bit. Try to get the temperature in the 70s. And put your hand in and see what it feels like. Better yet, try to get the temperature in the 50s or 60s and see what it feels like. You will be shocked at what it feels like. So 95 is actually perfect. When I had my first child, we were advised by my pediatrician, my child's pediatrician, to get it between 93 and 97 degrees. So this pediatrician in this story is saying that we would like it to be 95 degrees exactly, but we can vary from this as much as 3 degrees. So let's focus on a couple of things to start with. We want that, but we can vary from this as much as 3 degrees. So let me ask you a few quick questions. Could I vary it 2 degrees? Could it be 2 degrees off? Someone raise their hand and tell us. Stacy, could it be 2 degrees off? No? Okay, I'll come back to you on another one because you totally blew it. But that's okay because I totally put you on the spot. Michael, can it be 2 degrees off? Okay, can it be 4 degrees off?
No.
Could it be 5 degrees off?
No.
Could it be 1 degree off?
Yes.
Okay, so now we understand what as much as 3 degrees means. It can be 3 degrees, 2 degrees, 1 degree, or exactly 95. But once I go over the 3, then that's not okay. Then the baby's in danger, right? If I go over the 3 degree distance. So now let's look at what is actually happening. So you don't have to write this down, you just need to watch. The doctor is saying 95 degrees is perfect. But you can vary it 3 degrees. I could do 1 degree, I could do 2 degrees, or I could do 3 degrees. So what would the temperature be if I varied it 3 degrees? If I went 3 degrees in that direction? Alex? So it would be 98 degrees. Is there another temperature that I could get the bath water to be if I varied it 3 degrees? How did you get 92? That's right. You're allowed to go in the other direction. It doesn't say you have to add 3. It says vary it. This word means distance. And so we're saying that we can go 3 in that direction and get to 92 degrees. Does this look familiar? Give me a thumbs up if this setup looks familiar to you. Okay, Laurel, what does it look like to you? A number line. What did it look like to you, Cheyenne? Number line? Okay. What if I took this out? Let's take this out. Does that look familiar to you? Give me a thumbs up if that looks familiar to you. Amari, what does it look like? A number line? Still looks like a number line. Garion? An and inequality? You mean if I did that, and then I did that, and that, and so what we are illustrating here is exactly what he said, which is that an absolute value inequality is the same thing as a compound inequality. And so this question asked us to write and solve an absolute value inequality. We already know the solution because it's just logical. Just think about it. The doctor said 95 degrees, but you can vary it as much as 3 degrees, which means you now have a range. It could be 92, 93, 94, 95, 96, 97, or 98 degrees, or any decimal in between. So an and inequality, just like Garion said, really represents a range of numbers. That's what you're seeing here, a range of numbers. Does anyone have any questions about that? So now we have to learn, how do we write an absolute value inequality from this information so that it ends up looking like this? That's a little bit harder, but once you learn how to do it, it's actually not that big a deal. So I said that you didn't need to copy that, but now you need to start working along with me. We're going to use a model, and when I say a model, that means that I'm going to model something and you're going to use that same exact model over and over again. An absolute value, we're going to put something inside here. We're going to either have this symbol or this one. It kind of depends on these words. And then we're going to put a number right here. And here's how it works. The distance always goes right here. That's going to be the distance away. Right here is going to be what's called the given number. And when I say given, I'm talking about the number that's the one that we're really looking for, the one that the doctor recommends. It's the recommended number. And then right here, you're always going to put a variable and then a subtraction sign. So you just have to worry about two locations. You have to figure out what goes here and what goes here. You have one number here, one number here. You just have to figure out which one goes where. The distance is the one that says vary or differ or distance or something like that. So in this case, it's varying as much as 3 degrees. And what's the given number? What's the recommended number? It's 95. That's going to go there. Now solve it. We already know what the solution is. We just saw it. The solution is because we just thought about it logically. If I add 3 to 95, I end up at 98. If I subtract 3 from 95, I end up at 92. That's the solution. That is the absolute value inequality that solves to get that solution. You have to be able to do both. Now, that was not really enough to really get you mastering this idea, but it's enough to get you started. I believe you're going to have 4 or 5 questions on your homework that involve this, and you're going to have to make a really good effort. There are also examples in the book and online. So I've taught you how to access your account online. You can watch the videos that way as well if you need more assistance. So, draw a line across your paper. Your homework is the practice worksheet C, which I'm going to hand out to you in a moment. On the front, you're doing 1 through 10. On the back, you're doing 1 through 4. And you're going to have your Chapter 2 test next week.